Okay, today's lesson is understanding what the inverse of a statement is. So very simply, the inverse of a statement is taking the negation or to negate the actual statement. So to take the inverse of a statement simply means make the statement negative. Use the word not or no. Let's take an example. Example 1, I am happy. So to negate that statement, what you say is, I am not happy. You don't want to say I am sad because just because you're not happy does not mean you're sad. You might be angry. So the negation of I am happy is I am not happy, and that is the inverse. Let's take another example. Today is Thursday. If I want to take the inverse of today is Thursday, what I'm going to do is I'm going to negate it. In other words, today is not Thursday. It might be Friday, it might be Tuesday, it might be Wednesday, it might be Saturday. But that's not the point. To negate today is Thursday, to take its inverse means to say today is not Thursday. Let's take another example. I did not go to school today. Notice how the negation is already in my original statement. But when you negate a negative, you make it positive. So to take the inverse of I did not go to school yesterday, not today, if I did not go to school yesterday, to take the inverse of that means to negate did not. And when you negate a negative, it becomes a positive. So you would say I did go to school yesterday, or I went to school yesterday. These examples belong in your notes. If you need to, put your player on pause, but take them down. Let's take a look at a fourth example. All triangles are polygons. So there are two ways you can do this. You can say all triangles are not polygons, or not all triangles are polygons, or it's not true that all triangles are polygons. Either way, you're negating this statement. Let's take the fifth and final one. I am not happy. Again, notice how in the statement we have a negative. And when we want to take the inverse of the statement, we have to negate the negative. And when you negate a negative, you make it positive. So I am not happy. To take the inverse of that, I am happy. Let's talk about taking the inverse of a conditional. So remember, a conditional has a premise and a conclusion, or a hypothesis and a conclusion. So when you take the inverse of a conditional, what you're doing is you're negating both the hypothesis and the conclusion, or both the premise and the conclusion. This belongs in your notes, to make sure you take them down. Let's take an example, and these examples belong in your notes as well. If today is Monday, then I eat PB&J for lunch. So I'm going to negate both the premise and conclusion. If today is not Monday, then I do not eat PB&J for lunch. Okay, I simply negated both the premise and conclusion. Let's take another example. If the quadrilateral is a square, then the figure is a rectangle. So I'm going to negate the quadrilateral is a square, and I'm going to negate the figure is a rectangle. So if the quadrilateral is not a square, then the figure is not a rectangle. Take these down in your notes. You need these as examples. Let's take a third example. If two lines are parallel, they never intersect. So I'm going to negate both the premise and the conclusion. If two lines are not parallel, then they always intersect. When you negate never, what you say is always. The opposite of never is always. Let's take another example. If you live in Chicago, then you live in Illinois. So I'm going to negate you live in Chicago, and then I'm going to negate you live in Illinois to create the inverse. So if you do not live in Chicago, then you do not live in Illinois. Let's take these examples down. Let's take another one having to do with geometry. If a figure is a quadrilateral, it has four sides. So the inverse of that is if a figure is not a quadrilateral, it does not have four sides. Let's take one more example. Well, we're done with our examples. The question is the inverse of a statement always true? Let's go to the very top. So the very first one is if today is Monday, then I eat PB&J for lunch. And the inverse was if today is not Monday, then I do not eat PB&J for lunch. Is this necessarily true? What is the truth value or the truth false value of this statement? Well, let's think about this for a moment. Did it say that I only eat PB&J on Monday? No, it just says if it's Monday, I eat PB&J. But maybe I eat PB&J every day of the week, Tuesday through Friday as well. So just because today is not Monday, that does not mean I don't eat PB&J for lunch. So the inverse is false. In other words, it's quite possible that I do eat peanut butter and jelly, and even though it is not Monday, I still eat PB&J. Let's take a look at another one. If the quadrilateral is a square, then the figure is a rectangle. We said that the inverse is if the quadrilateral is not a square, then the figure is not a rectangle. Well, let's see. Let's come up with a counterexample. In other words, are there quadrilaterals that are not squares, but that are rectangles? Well, of course there are. Here's a quadrilateral that is not a square, but is a rectangle. A rectangle. There you go. So the truth false value of this is false. In other words, I just came up with a counterexample. Here is a polygon that is not a square. It's a four-sided figure that is not a square, but is a rectangle. Let's take a look at another one. If two lines are parallel, they never intersect. And we said that the inverse is if two lines are not parallel, then they always intersect. So you might say to yourself, well, wait a second, that's pretty obvious. I mean, clearly, if two lines are parallel, they never intersect. So we know that the conditional statement is true. And its inverse looks like it's also true. Eventually, these two lines are going to converge, and they're going to cross each other. But here's the thing. We never said two lines on the same plane. In other words, you can have two lines that are on different planes that are not parallel, and they also never intersect. And those, if you remember, are called skew lines. So skew lines are lines that are not parallel, and they also never intersect. If you don't remember what skew lines are, look back at your notes, because I know that you took the definition of skew lines down with a diagram. So the answer to this is also false. Let's take a look at the next one. The inverse was, if you do not live in Chicago, then you do not live in Illinois. Is that true? Is Chicago the only city in Illinois? And the answer is no, it's not. You can live in Peoria, Illinois. You can live in Davenport. You can live in Springfield. These are all other cities in Illinois. So just because you don't live in Chicago does not mean you do not live in Illinois. So again, this one is also false. So let's make that false. Next, if a figure is a quadrilateral, it has four sides. The inverse was, if a figure is not a quadrilateral, it does not have four sides. So, is that true? Well, if it's not a quadrilateral, that means quadrilateral is what again? The definition of a quadrilateral is a four-sided figure. So if it's not a quadrilateral, that means it is not a four-sided figure, which means it cannot possibly have four sides. So this inverse is true. So is the inverse of a conditional statement always true? It is not always true. Sometimes it is. Sometimes it isn't. It depends on the question. Here's what I'd like for you to do. So for these two conditional statements, I want you to write the inverse of each statement. I want you to determine the truth value of each. And then if it's not true, you need to find a counterexample. Put your player on pause, try to do these two, and then when you're done, hit play and compare your answers. Okay. The first one says, if a polygon is a pentagon, then it has five sides. We're going to take the inverse of this statement. We're going to take the inverse of this statement. So we're going to negate the premise and the conclusion. So if a polygon is a pentagon, then it has five sides. If a polygon is not a pentagon, then it does not have five sides. Well, what is the definition of a pentagon? We haven't really learned it yet, but a pentagon is a five-sided figure. So if it's not a pentagon, that means it is not a five-sided figure. Therefore, it cannot possibly have five sides. So it is true. Let's take a look at the next one. If an animal is a bird, then it has wings. Okay, so we know that if an animal is a bird, then it does have wings. Whether or not it flies is a separate issue. But the conditional is definitely true. How about its inverse? So we're going to take the inverse by negating the premise and conclusion. So if an animal is not a bird, then it does not have wings. Well, is that true? If it's not a bird, then it doesn't have wings. How about a mosquito? How about a bat or a fly? In other words, I can come up with innumerable counterexamples. Something that is not a bird, yet does have wings. So in the case of the first conditional statement, its inverse is true. In the case of the second, its inverse is false. I hope that was helpful. Take a look on Jupyter and look for your homework.